What is up, mathematicians? Welcome to day 5 of At Home Learning. It is a great day to be a mathematician. We are going to continue with section 4 from yesterday. We learned how to multiply and divide radicals and then simplify them. Today we're going to do a process called rationalizing the denominator. So it's not common practice to have a simplified answer that contains radical in the denominator. So whenever you get, so your final answer can't ever have a radical in the denominator. Whenever you get rid of that, it's called rationalizing the denominator. It's a fairly easy process to do. What you'll do is just most of the time you'll just kind of multiply something, the denominator by itself, and that will get rid of it. So you have to, like if you're looking at example 1, very, very easy to rationalize. To get rid of the square root of 7, you multiply the bottom by the square root of 7. So you just have to remember, whatever you do to the bottom of a denominator, you have to do the top of the fraction as well to the numerator. So on top, we have 2 times the square root of 7, which is, of course, 2 square roots of 7. On bottom, we have the square root of 7 times the square root of 7, which, of course, is the square root of 49. But the square root of 49 is just 7. And then you just have to check if your answer reduces. 2 over 7 doesn't reduce. The square root of 7 doesn't simplify any further. So that's as far as that one is going to go. If we look at number 2, if we were to put that as a whole radical, it wouldn't help us out because we can't reduce 5 and 12. So we need to get rid of that radical in the denominator by multiplying the top and bottom by the square root of 12. On top, the square root of 5 times the square root of 12 is going to be the square root of 60. On bottom, the square root of 12 times the square root of 12 is, the square root of 144, but that's just 12. Then we have to check this one. Does that top simplify? And the answer is yes. What perfect square divides 60? And it's 4 times 15 is the same as the square root of 60. And the square root of 4 is 2. So it's going to be 2 square roots of 15 over 12. And that's going to reduce the 2 and 12. Those can reduce by 2 to give you the square root of 15 over 6. And there's no other perfect square that divides 15, so that's as simplified as it will get. Number 3, this one you'd want to separate into the 2 separate radicals. On top, you'd have the square root of 1. On bottom, you'd have the square root of 18x. And then to rationalize that, you would multiply the top and bottom by the square root of 18x. So on top, what's 1 times 18x? That's still the square root of 18x. On bottom, the square root of 18x times the square root of 18x is going to be plain old 18x. And then again, look at that numerator. There's a perfect square that divides 18. So we'd want to break that into the square root of 9 times the square root of 2x. I'm going to keep those separate since that's not going to go any further. 9 times 2x is still 18x. On bottom, we still have the 18x. Square root of 9 is 3. So 3 square roots of 2x over 18x. And once again, that will reduce just slightly. The 3 and the 18 are both divisible by 3. If you divide each of those by 3, you're going to have 1 square root of 2x, or just the square root of 2x on top, and 18 divided by 3 is 6, so 6x. And again, we can't cancel out those x's because that one's inside of the radical, that one is not. We can't cancel the 2's and the 6's for the same reason. And the same reason we couldn't simplify 2 any further. That one's in a radical, that one's not. 4, 5, and 6 are much like 1, 2, and 3. So if you want to pause the video here and try those, see if you can get the matching answers, that'd be great. Otherwise, I'll continue working them. So pause and try, and here we go. This one, you multiply the top and bottom by the square root of 5. So that gives you 4 square roots of 5 over 5. And again, that one doesn't reduce, much like number 1. Number 5, if you multiply the top and bottom by the square root of 18, you would have the square root of 54 over 18. There is a perfect square that divides 54. It is 9 times 6. So that would be 3 square roots of 6 over 18. And the 3 and the 18 reduced by 3 to leave you with just the square root of 6 on top. And 18 divided by 3 is 6. And again, that's as far as that reduces because that's inside of the radical. The top is and the bottom is not, so you can't simplify it any further. Number 6, again, start by separating it to the square root of 3 on top, the square root of 14x on bottom. You would multiply the top and bottom by the square root of 14x. That's going to produce the square root of 42x on top and normal 14x on bottom. Is there a perfect square that divides 42? 4 does. So we could divide it by 4. That would be 4 times, no, 4 doesn't divide it. That's not right. 4, 9 doesn't divide it. 16 doesn't divide it. 25, 36. Yeah, that doesn't reduce any further. So that's as far as that one will go. So there you go. Now with cubes, here's where it gets a little trickier. So rationalizing squares is pretty simple because you just multiply it by itself. For cubes, you want to make it into a perfect cube. So you can't multiply it by itself because that's not going to make a perfect cube. So for these, you really need to know your perfect cube. So I'm going to rewrite them again. 1 cubed is 1. We won't ever use that one. 2 cubed is 8. We'll use that one a lot. 3 cubed is 27. Also going to be used a lot. 4 cubed is 64. And then 5 cubed is 125. So those are the cubes that you hopefully know by now. So we need to make it into one of these numbers. Either 1, which we won't ever do that, but 8, 27, 64, or 125. So which one can I make 4 go to easiest? I can make it go to 8 very easily by multiplying by the cube root of 2, because 4 times 2 gives me 8. If I multiply the bottom by the cube root of 2, I have to multiply the top by the cube root of 2. So on top, I would have 5 cube roots of 2. On bottom, 4 times 2 is 8, so I would have the cube root of 8. But we know that the cube root of 8 is 2, so it simplifies to 5 cube roots of 2 over 2, which does not reduce any further, so that's going to be the simplified answer. Again, for the bottom, which of the perfect cubes can we get to easiest? I can get to 27 pretty easily. I think that's the easiest one. We always want to go to the smallest number possible because that's going to make the least amount of simplification later. So what can I multiply 3 by to get to 27? I can multiply it by 9. So we'd multiply by the cube root of 9. And again, if you do that to the bottom of the fraction, you have to do it to the top of the fraction. So on top, I have the cube root of 63. On bottom, I have the cube root of 27. We know the cube root of 27 is 3. Is there a perfect cube that divides 63? 8 doesn't divide it, 27 doesn't divide it, and then 64 is too big. So it doesn't simplify any further than that. It's the cube root of 63 over 3. If you want to try 3 and 4, that'd be awesome. So pause it here, try those, see if you can get them. I'll go ahead and start on them. So what perfect cube can I get 25 to? Well, clearly I can get it to 125. How do I do that? Multiply by 5. But just the cube root of 5, right? And then on top, I'd have to multiply it by the same thing to keep it balanced. So 3 times the cube root of 5 is 3 cube roots of 5. On bottom, I have the cube root of 125, but we know that the cube root of 125 is plane 5. So we have 3 cube roots of 5 over 5. Again, doesn't reduce any further. If we look at 4, I can't multiply 5 by anything to get to 8, 27, or 64, so again, I need to make it 125. So 5 times 25 is 125, so I'd multiply the cube root of 5 by the cube root of 25. And then again, we'd have to do that to the top as well. 6 times 25. If you had 6 quarters, that would be $1.50, so it's going to be the cube root of 150. On bottom, we have the cube root of 125 created on purpose so that it would turn into plane 5. Is there a perfect cube that divides 150? 8 doesn't divide it, 27 doesn't divide it, 64 doesn't divide it, and clearly 125 doesn't. So it's just going to stay the cube root of 150 over 5, and that's simplified. So there's rationalizing single things. On the back, we learn how to rationalize a denominator that has a sum. And we can do that by multiplying by whatever the denominator's conjugate is. So the conjugate is the same thing as the sum except for just the opposite sign. So, the square root of 4 minus 3 is the conjugate of the square root of 4 plus 3. And then the square root of 4 plus 3 is the conjugate of the square root of 4 minus 3. So you just notice the conjugate is the same numbers, just an opposite sign. So we can rationalize that sum by multiplying by the conjugate. So the conjugate of 1 plus the square root of 3 is going to be 1 minus the square root of 3. And if I multiply the bottom by 1 minus the square root of 3, I have to multiply the top by 1 minus the square root of 3. So on top we would distribute. 2 times 1 gives me 2, and then minus 2 times the square root of 3 is just 2 square roots of 3. On bottom there, that's going to be FOILed out, but you'll see why multiplying by the conjugate is very convenient. But we'll work this one out, and the rest we probably won't have to. So if we were to distribute that 1, let me get a different color in here so we can see my arrows. 1 times 1 is 1, and then 1 times that negative square root of 3 is negative 1 square root of 3. You don't need to really put the 1 out front. You could if you wanted to. So we've distributed the 1. Now we distribute the square root of 3. The square root of 3 times 1 is a positive square root of 3. The square root of 3 times that negative square root of 3 is going to be minus. What's the square root of 3 times the square root of 3? It's the square root of 9, but what's the square root of 9? It's 3. So remember, the square root of 3 times the square root of 3 is just 3. So what this does, the conjugate is always going to make those two middle terms opposites. So you'll notice we have a negative square root of 3 and a positive square root of 3. Those two middle terms will always cancel out when you multiply by the conjugate. That's why we do it, because it will always get rid of the radicals in the denominators, which is what the goal of this was. So on top, we can't really put those together, so it's just going to be 2 minus 2 square roots of 3. On bottom, we just have a little bit of math to do. 1 minus 3 is negative 2. Now I'm looking at that answer and it reduces because, and to reduce these, everything has to be divisible by the same thing. So all of these are divisible by 2. 2 is divisible by 2, and that 2 is divisible by 2. But we're also dividing by a negative 2, so it's going to simplify a little bit further than that. So 2 divided by negative 2 is negative 1. Negative 2 divided by negative 2 is going to be positive 1, and then square root of 3. It's a little weird to have that 1 there, so I'd probably just write it as negative 1 plus the square root of 3 for my final answer there. So I showed a lot of work here. What I'm going to do from now on is I'm going to not multiply this part and that part. I might do it on 1 or 2 others just to show you, but once you get comfortable with the process, you can just really do the first term times the first term, and the last term times the last term, if you're thinking about FOIL. So anytime you have a sum and a denominator, you have to multiply by the conjugate. So we're going to multiply by the square root of 5 plus 1 is the conjugate of the square root of 5 minus 1. And then again, if I do something to the top or to the bottom, I also have to do it to the top. So on top, we've got a foiling to do. So let's distribute that first term. The square root of 5 times the square root of 5 is 5. The square root of 5 times 1 is the square root of 5. 4 times the square root of 5 is 4 square roots of 5. And then 4 times 1 is 4. So obviously I'm going to be able to put some things together, but before I do that, I'm going to go ahead and multiply my denominator out as well. So again, I have the square root of 5 times the square root of 5, that's 5. I have the square root of 5 times 1, that's the square root of 5. I have negative 1 times the square root of 5, which is the negative square root of 5. And then I have negative 1 times positive 1, which is negative 1. Okay. So let's look at what we have on top there. On top, we've got 5 plus 4, so that's 9. And then we have the understood 1 square root of 5 plus 4 square roots of 5. So that's going to be 5 square roots of 5. On bottom, I've got the 5 minus 1, that's 4. And I have 1 square root of 5 minus 1 square root of 5. Those cancel, that's always going to be the case. And I look at this answer, nothing is reducible on this one, so that's going to be the final answer for that. So number 3, again, anytime you have a sum or a difference in a denominator, you multiply by the conjugate. So the conjugate is going to be 1 minus the square root of x in this case, which means the top will need to be multiplied by 1 minus the square root of x. If you distribute that top, you're going to have 3 minus 3 square roots of x. On bottom, I know that those two middle terms are going to cancel, so this time I'm just going to do the first part and the last part. So I'm going to do 1 times 1, and I'm going to do the square root of x times the square root of x, or the negative square root of x, which is just going to be minus x, right? The square root of x times the square root of x is x. So I look at that, and it's a weird answer, but nothing, again, reduces, so that's all you had to do there. If you want to pause the video and try 4, 5, and 6, that would be good. They match 1, 2, and 3 above, so you can kind of look at those for hints. But I'll go ahead and get started here. The conjugate of 1 plus the square root of 5 is 1 minus the square root of 5, which means I have to multiply the top by it as well. If I distribute that 4, I would have 4 minus 4 square roots of 5. On bottom, I just have to do the first and the last part. So that would be 1 times 1, and the square root of 5 times the negative square root of 5, which is minus 5. So I can do that math in the bottom. 1 minus 5 is negative 4. So 4 minus 4 square roots of 5 over negative 4. Much like number 1, all of these terms are divisible by that 4. So we're going to reduce that. 4 divided by negative 4 is negative 1. A negative divided by a negative is a positive. I don't need the 1. The 4's just kind of cancel, leaving me with the square root of 5. So that turns into negative 1 plus the square root of 5, which is really kind of interesting to think about. 4 divided by 1 plus the square root of 5 is equal to negative 1 plus the square root of 5. It's kind of interesting just to think about. Those are equivalent, which is just kind of weird. And you could type that into a calculator and see that they are equivalent if you wanted to. Number 5, what's the conjugate of the square root of 3 minus 1? It would be the square root of 3 plus 1. So that gets multiplied to the top as well. So the top's going to all have to be distributed. The square root of 3 times the square root of 3 is 3. The square root of 3 times 1 is the square root of 3. 2 times the square root of 3 is 2 square roots of 3. And 2 times 1 is 2. On bottom, just doing the first and the last, the square root of 3 times the square root of 3 is 3. And negative 1 times positive 1 is negative 1. So put your like terms together in your numerator, and you have 5 plus, remember this is an understood 1, so 1 square root of 3 plus 2 square roots of 3 is 3 square roots of 3. On bottom, 3 minus 1 is 2. And that doesn't reduce again, so that's going to be the final answer there. 6, just multiply by the conjugate, 5 plus the square root of x to the top and bottom. Distribute that 8 through, and you've got 40 plus 8 square roots of x. On bottom, multiplying the first and last together, 5 times 5 is 25. The negative square root of x times the positive square root of x is x. And again, it's a weird looking answer, but that is the simplified answer. These last two examples are just examples showing, make sure that your final answer is reduced if you get something like this. What do you notice? You should hopefully notice that the square root of 18 simplifies. The square root of 18 is the same as 9 times 2. So that simplifies to 12 minus 3 square roots of 2 over 9. So if you get an answer like this, all of the coefficients are divisible by 3, so you'd want to divide them by 3. And that's going to give you 4 minus 1 square root of 2, but you don't need the 1, so just the square root of 2 over 3. And that is simplified. 8's very similar. You can pause it and try it if you want. But I'll go ahead and do it here. You look at 28, and that is 4 times 7. So that's going to be 14 minus 2 square roots of 7 over 6. All of those coefficients are divisible by 2. So that's going to give you a final answer of 7 minus the square root of 7 over 3. So hopefully all this makes sense. Let me know if you need any help with any of it. I'll be looking forward to hearing from you. Have a great day and have a good weekend. I will see you again on Monday.